but now we're on the third part. We're into y equals ax squared plus bx plus c. When we're doing this type of problem, at first we're not going to compare it to the parent function. We just want to graph this quadratic function. The very first thing that we need to do is we need to identify what our a, b, and c values are. Our a value is the coefficient of the x squared term, so the a is positive 2. Now, if a is greater than 0, we know right off the bat we're talking about an upward pointing quadratic function. Okay, so right off the bat we know that this function is going to look something like this, kind of like a touchdown. It's an upward pointing function. Our b, now remember it's plus bx, so we know that minus 8x, that would be a negative 8. And we know that our c value is a positive 6. So I've identified my a, b, and my c. I could go over here and do the graph and the table, fill in 5 points for x, 5 values for x. To determine my y, I can have my ordered pairs. There's other ways to skin a cat. Well, the way we're going to skin this cat to be able to graph this is to first find the vertex. To be able to find the vertex, we can find the x value of our coordinate pair by saying x equals opposite b over 2a. Now, I know from finding my b, I have a b value of negative 8 and I have an a value of 2. So I can go right over here and I can say x equals the opposite of negative 8 all over twice 2. Opposite of negative 8 is 8 over 4. My x is 2. So my x value in my ordered pair is 2 something. I have to find the y part to my coordinate pair, ordered pair, 2 something. So I can take my original function, and wherever I see an x, I can plug in a 2. So I've got 2 times 2 squared minus 8 times 2 plus 6. 8 minus 16 plus 6. Negative 8 plus 6. My y value should be negative 2. So my vertex for my function should be at 2, negative 2. And remember, we know because it's a positive a value that it's going upward. Now, we have the vertex. Now, there's one more thing about this function. Whatever my c value is, that is my y-intercept. So I know that my c is 6, so my y-intercept is 0, 6. My y-intercept is 0, 6. Okay? Now, we talked about this, but what goes through the vertex and cuts the quadratic function in half? Your axis of symmetry. So I can go ahead and I can take my dotted line to the best of my ability and the best of your ability and create your axis of symmetry for this quadratic function. So what have we done so far? We have found the vertex by finding the x part. We've used that 2 value, plugged it back into the function to find our y, which gives us the y part of the ordered pair. 2, negative 2 is my vertex. We know it's going to go upward because we've got a positive 2. We've also found the y-intercept. The y-intercept is our c value, so our y-intercept is 0, 6. Now here's the key. We need to create a point on that side of the axis of symmetry. So if this is 0, 6, let's go 2 units on this side of the axis of symmetry, and then up to the 6, and we reflected the y-intercept across the axis of symmetry. There's one more thing we need to do. We need to find one more point. Let's use y equals 1. let's use x equals 1. Let's put x equals 1 back into the original equation to create a second point. Y equals 2x squared minus 8x plus 6. Wherever I see an x, I'm going to plug in my 1. My y value is 0. So, in the green here at the bottom, by me choosing x equals 1, putting it back into my function, I've created yet another ordered pair. 1, 0. I've created another ordered pair that will help me when I'm doing my graph. What do we need to do? We need to reflect it across the axis of symmetry. You should have talked about this a little bit in geometry. We'll get to it more in class, but we reflect it across. Bam. That is the reflection. Okay? Now, let's make sure we understand what we have here. We have the function. We've identified our A, B, and C. We found our vertex in green and blue. We know that x equals opposite of b over 2a. That gave us our x value. We can plug our x value back in to give us our y value. Bam! We've got our vertex. That is the vertex. Good enough. Our y-intercept is our c value. So that is the y-intercept. What is this right here? That's the reflection of the y-intercept. And then we needed one more point. So I chose an easy value for x, 1. If I choose x as 1, I plug it into my function, I can find y, I find my last point. So there's my last point right there. That was 1, 0. And then I've got a reflection. Now the last part is to actually graph the function. This is a narrow function. And it looks something like that. That is part 3 of lesson 1.1, graphing y equals ax squared plus bx plus c.